Okay, 83 looks like a tough problem. It says prove the area under one arch of the cycloid is equal to 3 pi r squared. So I'm going to go to the whiteboard and walk you through it. All right, so let's go to the whiteboard, and I'll pull that up. And again, we're on problem number 83. As I write these things down, I encourage you also to give it your best shot, by the way. So this is 83. And I'm going to say x is a function of t. And that function is this over here. It's r times t minus sine of t. I'm going to say y is also a function of t. R is a parameter that's fixed. And it's going to be r times 1 minus the cosine of t. Now, whether you recognize it or not, they tell you in the words that this is a cycloid. So I'm going to put this down and say a cycloid looks sort of like this over here. And it keeps repeating itself, by the way. They just want me to do one cycle of it. So, I'm going to pick one that's convenient for me. All right, I'm going to pick something. I'm going to start somewhere. I'm going to say it looks likely that it's starting at t equals 0. All right? By the way, this is the x-axis. And I'm going to move along for one cycle. So let me see if that's true. If t is 0, would I get that point there? Well, what's x of 0? X of 0 would be r times, well, let's see, 0 minus sine of 0, which is 0. It would certainly be 0. So let me write this down. So the point here, I got to get the y now. Y is 0. I'm happy about it starting at 0, by the way. It's going to be r times 1 minus cosine of 0, which is 1. It's also 0. So I got a point over here. It's a rather convenient point. And what's that going to be? It's going to be 0, 0. And what I want to do is I want to march along, and I want to figure out where it stops over here. Now, what's convenient from here? I don't know what the number is yet. I'm going to say what I do know. I know y evaluates to 0. So when I start thinking about it, I'll write this down. So y of t is equal to r 1 minus cosine of t. Now, the only way that could happen is if the cosine of t is equal to 1, and the cosine of t equals to 1 at 0, and the next time it happens is at 2 pi. So I'm going to say y at 2 pi. Let's write that down. It's going to be r 1. The cosine of 2 pi is 1, so that's certainly 0. Now, someone could say, I wonder what the x is. Well, let's write it down. 2 pi. It's going to be r times 2 pi. Again, we're using these formulas up here. And then it's going to be sine of 2 pi, which is 0. So r 2 pi. It's over here somewhere. So it's going to be r 2 pi, and it's going to be 0. So right now, I'm sort of ready to set my integral up. I know my cycle. I'm going to start to erase things now. I'm pretty convinced that this is okay. And let me just remind you here that this is t equals 0, and this cycle stopped at 2 pi. All right? So I want to talk about, let me erase other parts of the picture I don't need anymore. I don't need this. By the way, this is still the x-axis, by the way. I'm going to look at one sliver, just over here, and I want the area of it. So the width of it is dx, and the height of it is going to be what the y is. And what's the y going to be? Well, y is a function of t. It equals this over here. So let's write this down. So the area is going to be r, the height, 1 minus cosine of t, and then I got to write down the width, which is dx. By the way, I'm kind of curious about the limits of integration, but I got something mixed here. I got x's and t's. I can't have that. So what I want to write down is a differential dx. And I'm looking at that. Upon what I'm looking at, this over here. I need to differentiate. What do you get? You're going to get r. Sorry about that. You're going to get r. And then you're going to get derivative of t is 1. minus, we're doing dt now, cosine of t dt. Well, isn't that convenient? And I'll tell you why. I'm looking at that, I start to realize it's going to be r squared, 1 minus cosine squared. And what do I get now? I get dt now. So now I get everything in terms of the t. Now where does the t start? At 0. Where does it stop? At 2 pi. All right? So this is my first milestone, getting here. What I have to do now, I have to expand it. And as I expand those things, I'll write this one down for you. This is going to be r squared. It's going to be 0 to 2 pi. This is going to be 1 minus 2 cosine of t plus cosine squared t dt. Well, the first two terms are trivial to integrate. That cosine squared, I got to remind myself, and let me just remind you over here, that cosine of 2 theta is the same thing as 2 cosine squared theta minus 1. So cosine 2 theta plus 1 over 2 is cosine squared theta. I'm going to write that down now. R squared, 0 to 2 pi, 1 minus 2 cosine t plus, this is going to be cosine 2t plus 1 over 2, and this is going to be dt. All right? Let me get my eraser out. I need a little help doing that. Since I can't remember things, I just write things down I can remember. I'm going to factor out the 2 on the bottom. And what do I get? I get r squared over 2, and then you're going to get 0 to 2 pi. This will be 2. This will be 4. And then I get cosine 2t plus 1 dt. Going to continue to simplify. This is going to be r squared over 2, and then I get 0 to 2 pi. Here I get 3 minus 4 cosine of t plus cosine of 2t dt. Well, I got some integration to do now. It doesn't look bad. Right. I also know what I'm aiming for. They told me it's going to be 3 pi r squared, but I don't know that yet. Maybe there's a mistake somewhere. Let's write this down. It's going to be 3t minus 4 times the antidot of cosine. That's going to be minus 4. Let's see, sine of t. Let me make sure that's true. Yeah, that's good. And then what do you get? Minus, I'm sorry, minus, I'm not minus, plus sine of 2t over 2. Limits of integration go from 0 to 2 pi. All right, let's write this down. So r squared over 2. We're going to evaluate the upper limit, and what do you get there? You get 3 times 2 pi minus, the second term evaluated 2 pi is 0, and the third term would also evaluate to 0. That was pretty easy. Minus, let's do the lower limit, r squared over 2, evaluate 0, so 0 minus 0 plus 0. Well, isn't that convenient? What are you left off with? You're left off with r squared over 2 times 6 pi, which would give me 3 pi r squared. Is that what they want me to show? It is. We're done. We're good to go. Thank you.